Climate change is a major challenge for our international community and the world. Combating climate change and mitigating its adverse effects is one of the highest priorities for many governments. And so, boosting energy efficiency and promoting energy-efficient products is key for tackling climate change. A perfect example of an energy-efficient product is a vacuum insulation panel. A vacuum insulation panel, or VIP for short, is a revolutionary insulation product that is already fighting back and tackling the negative effects of climate change by stopping valuable loss of energy. VIPs are ultra-thin, high-performing insulation materials that consist of a rigid, highly porous core material encased in a thin, gas-tight outer envelope, which is evacuated and sealed to prevent outside gases and humidity from entering the panel. VIPs are much more effective than traditional insulation products. They are high-performing thermal insulation panels with a thermal conductivity 5 to 10 times better than other conventional insulation materials. In consequence, the insulation thicknesses can be reduced by a factor of 5 to 10 as well. This ends up increasing volume capacity of applications for which a lack of space for insulation thickness is an issue. They have a very stable, long-term thermal performance when installed correctly and protected from damage and penetration. VIP products are already being widely used in several industries. In the building industry, they are used in areas including roofs, floors, facades and walls, contributing to saving space and reducing the use of energy. Within the transport sector, they are used in refrigerated trucks and transportation systems, as well as in trains, electrical vehicles, ships and airplanes. In the home environment, they are used in appliances like refrigerators, freezers and water boilers, increasing their energy efficiency and their usable internal volume. They are also used in temperature-controlled packaging for medical and pharmaceutical industries, vending machines and cold store units, contributing to keeping valuable materials in optimal conditions and keeping the containers compact. In consequence, shipping costs for cold chain packaging can be reduced significantly.
How are vacuum insulation panels made? Vacuum insulation panels are an optimum performance next-generation insulation solution. They are made by pressing a dry mix into a specific shape. This helps to remove any air from the insulation. The compressed core is then inserted within a fleece coating, which gives it protection from any dust. This is slowly cooked to dry it out as much as possible. A foil facing is wrapped around the insulation and a vacuum chamber is used to remove any further air. To finish, the edges of the vacuum insulation panels are sealed. The panel surface should look wrinkled. If it looks smooth, then air has entered the insulation and the thermal performance will not be as good.
Core materials are dried through the channel. Put into the vacuum equipment after enveloped. Check the product's layout in order. VIPs come out from the vacuum equipment. Stick the labels for quality tracking. Rolling machine to ensure the evenness. Manually folded. Protect each edge and quarter properly. Test the thermal conductivity after 72 hours layup.
How to install vacuum insulation panels below a floor screed. Concrete slabs should be allowed to dry out prior to the installation of the vacuum insulation panels. On average, this is 1 day per millimetre of slab thickness. The surface of the slab should be smooth, flat and free from projections. Beam and block floors should be level and grouted. If a damp-proof membrane is required, it should be laid with joints well lapped and folded over the concrete slab or beam and block floor prior to installing the vacuum insulation panels. The membrane should be brought up the surrounding walls until it is sufficiently high enough to connect with or form the wall damp-proof course. A protection layer is recommended at this stage. This should be installed over the damp-proof membrane or substrate before installing the vacuum insulation panels. A strip of appropriate insulation should be placed vertically around the perimeter of the room in order to reduce cold bridging. The top should be level with the top of the floor screed. The bottom should be level with the bottom of the horizontal floor insulation. Next, the vacuum insulation panels should be installed. These should be loose laid with joints lightly butted and film flaps facing down. Starting at each external corner of the floor, lay the vacuum insulation panels in a break bond pattern. They should be closely butted up to the strip of insulation at the perimeter. An appropriate rigid insulation infill board is required wherever runs of the vacuum insulation panels do not fit. At this stage, another protection layer should be laid, followed by an appropriate separation layer to act as a vapour control layer. Ensure that the separation layer has 150mm overlaps taped at the joints and is turned up 100mm at the walls. Finish with a floor screed laid to a minimum thickness as recommended by the screed supplier or manufacturer. If using a traditional sand and cement mix, the minimum thickness advised would be 65mm for domestic or 75mm for non-domestic.